All right, good morning, guys. Today we are going to do solving system of equations using Cramer's rule. All right, this is where all the algebra kind of comes in. So we taught you how to do systems using graphing, elimination, substitution, even on the graphing calculator. Now we want to try to show you how to do this using Cramer's rule, which invokes the matrices. This is why we needed to do all that matrix stuff. So let me start with the 2 variable. This is your 2 by 2. Okay. So imagine I have a system like this. 8x minus 6y equals negative 20. And negative 16x plus 7y equaling to 30. Okay. So first, we want to talk about it has to be in this format, the ax plus by equals to c. So whatever you have to do, you have to make sure it's in this format. Do you see your x's and y's? This is what we call your augmented matrix right here. So I'm going to take these numbers and find its determinant. So on the side, I have your 8, negative 6, negative 16, and 7. And find its determinant. I mean, you can, now we showed you how to use a calculator. You can use a calculator to find the determinant, or you can, a 2 by 2, it's simple. That's 56 minus your 96, and that's your negative 40. Okay. Now, watch how easy to solve for x and y using Cramer's method. Cramer's method states this. To solve for the variable x, see it? I'm going to replace the answers, see these answers, for x, and divide by this determinant. So instead of 8 and negative 16, I'm going to replace it with negative 20 and 30 because I'm solving for x. Y stayed the same, divided by your augmented matrix here, which is negative 40. And now you just have a determinant divided by that. And we end up with, this is negative 140 plus 180. And we end up with a negative 1. So the answer to x is negative 1. We're going to do the same thing for y. To solve for y, replace the y with the solution. So I have the matrix 8, negative 20, negative 16, and 30 divided by that negative 40. And we end up with 240 minus 320 over negative 40. And again, you can do this in the calculator. And we end up with 2. So the solution to this system is negative 1 comma 2. As you see, replace the variable with the, whatever it's equal to, and then divide by this augmented matrix right there. So that's a 2 by 2. We're going to do the same thing for a 3 by 3. Here you go. Let's do 3 variables. All right, so let's imagine I have this system, negative x minus 5y minus 5z equals to 2. 4x minus 5y plus 4z equals to 19. And x plus 5y minus z equaling to negative 20. All right, so here's my 3 by 3. And as you see, it's in the XYZ format equaling to something. So the first thing I'm going to do is grab my calculator and find this augmented matrix. So let me write that down for you. Negative 1, 5, negative 5, negative 5. 4, negative 5, 4. 1, 5, negative 1. And we showed you a couple of methods to figuring out the determinant of this. I use a calculator, of course. That's negative 150. And now here's the process for x, y, and z. So to solve for x, I know I got to divide by that negative 150, and I got to have a matrix. Now, so I'm going to replace x, these three right here, with those three. So I end up with 2, 19, negative 20. And then I'm going to rewrite the y's, negative 5, and 5, rewrite the z's, negative 5, 4, negative 1. This is why I like to do this here, because now in place of this, I'm going to write x. When we do y, we're going to replace this with the answers. And when we do z, we're just going to replace that. Okay, so we end up with 300 over negative 150, which is a negative 2. For the y's, same thing. So that's why I look at this. I now end up with negative 4, 1, negative 1, 4, 1. Now, instead of the y's, I'm going to put my solution to 19, negative 20, and my z stays the same. Divide that by negative 150. And I ended up with 450 over negative 150, which is negative 3. And finally, for z, the x and y stays the same. Now replace z with the solutions over your negative 150, and I end up with negative 450 over negative 150, which is 3. So my solution to this problem, x, y, z. So this is why we needed, this is the beginning. This is just the beginning of why we need the matrices. So this is how to solve a 2 by 2 and a 3 by 3. There's one more thing that I need to show you with a 2 by 2 and or a 3 by 3, and that sometimes when we solve systems, there might be infinitely many solutions, which means that they're the same line, or no solutions, that means that they must be parallel. So how do I determine that? Well, for a, let's do a 2 by 2 real quick. A 2 by 2. I got negative x minus y equals negative 1. Uh-oh, hold on. My focus is out for just a little bit. Hold on. Okay. There we go. It was out 3x plus 3y equals to 3. If I first find our augmented matrix, as you see, we end up with negative 3 plus 3, which is 0. So that tells me, first of all, I can't divide by 0. So now the question is it infinitely many solutions or no solutions? So how do I tell that? Well, hold on. Let me show you this other one right here before I move on. Negative 5x plus 5y equals to 10. Negative 2x plus 2y equals to negative 4. If I do the augmented matrix, negative 10 plus 10. So how do I tell which one is no solution and which one is infinitely many solution? And the answer to that is this. When I said infinitely many solution, that means they're the same line. That means they overlap, which means one equation must be a multiple of the other. As you see in this first one right here, if you multiply 3 times the top one, oh, I'm sorry, negative 3 times the top one, you end up with exactly the bottom one. Hence, this one is infinitely many. Where this one here, to multiply this, let's say if I multiply the bottom by 5/2. Here, we multiply the top by -3, we got the bottom. Here, if I multiply by 5/2, let's see, 5/2 times -2 is that -5. 5/2 times 2 is the +5. But 5/2 times the -4 is a -10 and not +10. So this is why in this case right here, this is a no solution. So this is why we start with the augmented matrix first. And we see that first, if you get a 0, it could be two possibilities, either infinitely or no solution. If it's infinitely, we look at the system. Is one a multiple of the other? If so, it's infinitely. If it's not, then it's a no solution. Same thing happens with the 3x3 when you do the augmented matrix. And then, let's see here. And if you get a 0 for a 3x3, if you get a 0, we tend to say it's a no solution because it's kind of hard to see that 1, 2, 3, one is multiple of the other one is a multiple of the other one. So if you get a 0, then in a 3x3, then we just say it's a no solution. But you know what? We still have to check. I mean, 99% it would be a no solution, but you never know that 1% it could be that infinitely many one. Okay, so I got the assignment for you, just in case. For the 2x2 worksheet, do problems 2, 4, 9, 12, and 14. And for the 3x3, do 2, 4, 6, 14, and 16. I need to see at least like these steps right here. You can use the you don't have to do this. You can use a calculator to get the determinant like I did over here to find a determinant. But this is what I need to see, so I'll make sure that you know what how to use Cramer's rule. And again, this is just the beginning of the process of matrices and why we use matrices. All right, guys. See you soon. Bye.